Hi everybody. Today we're going to take a look at properties of exponents involving products. If you want to follow along in the book, Algebra 1 People, it's on page 492. 8.1 is the exercises. If you go back 2 pages to page 489, this is where the examples are coming from. So if you want to follow along and kind of go, that's fine. If you don't, that's fine too. Okay, on example A, 7 to the third times 7 to the fifth. When we break that down, 7 to the third means 7 times 7 times 7, and then 7 to the fifth is 7 times 7 times 7 times 7 times 7. So when you have these exponents and you have the same base like we have right here, we have the base of 7 here and a base of 7 here. A shortcut to do this is to keep your base of 7 and then add your exponents. 3 plus 5 is 7 to the 8th. That's the shortcut. Otherwise, you go 7 to the third times 7 to the 5th, and you count the number of 7s you have. And so you have 1, 2, 3, 4, 5, 6, 7, 8. And so that exponent is telling you how many times to use that base number as a factor. So your shortcut there is to keep your base and add your exponents. When you look at example B, 9 times 9 to the 8th times 9 squared. Your base is 9, and then you count your exponents. So on your first 9, your exponent is an understood 1. So you have 1 plus 8 is 9, plus 2 is 11. So that you have 9 to the 11th. And again, if you wanted to expand that, 9 to the 1 is 9, and then 9 to the 8th. And then 9 squared. And remember, we're multiplying that base that many times. And so when you count those, you will have 9 as a factor 11 times. Example C is slightly different because we have a negative number as our base. Negative 5 is in parentheses, which means that that exponent has to be applied to everything in that set of parentheses. Negative 5 is our base here, and negative 5 is our base here. We have to keep that negative number in the parentheses, and the understood exponent when there is not one is a 1. So negative 5 is our base, and then 1 plus 6 is 7. When all you have as a base is a variable, as they do in example D, x is your base, and again we will add our exponents, 4 plus 3, and you have x to the 7th. If you go to example 2 on page 490, example 2a has 2 to the 5th power raised to the 3rd power. So what that means is we are going to use 2 to the 5th, and we're going to do that 3 times. So if you were to expand that, you would have 2 to the 5th expanded here, and then 2 to the 5th expanded again, and then 2 to the 5th expanded again. And so when you write your base of 2, and then you use 2 as a factor 5 times, and then you do that 3 times, you get 2 as a factor 15 times. So it's 2 to the 15th. So the shortcut on this is your base is 2, and when you have an exponent raised to another exponent, you multiply the exponents. 5 times 3 is 15. On example B, our base number is negative 6. Again, when you have a power raised to a power, you multiply. Negative 6 squared raised to the 5th. So negative 6, 2 times 5 is 10. So negative 6 raised to the 10th. You have to make sure that you keep that base number of negative 6 in parentheses. If your base number is a negative number, that negative number must go in parentheses. On example C, your base number is x. It is squared, and that square is raised to the 4th. So again, a power to a power, you multiply. So your base is x, 2 times 4 is 8, x to the 8th. D looks slightly different because our base number is a quantity. The base number is y plus 2. And that quantity is raised to the 6th power, and then that power is raised to another power of 2. So you have 6 times 2, which is 12. Example 3 is on page 491. There are A, B, C, and D problems for example 3. When we look at A, we have 24 times 13, and that product is raised to the 8th. Anytime you have entities inside a set of parentheses and that group is raised to a power, each entity has to be raised to that power. So we will have 24 raised to the 8th times 13 raised to the 8th. On B, 9xy squared means that we would do that again, 9xy, which means we would have 9 times 9, which is 81. X times x is x squared. Y times y is y squared. The shortcut on that is, again, this exponent of 2 has to be distributed to each single entity inside this set of parentheses, which means 9 squared would be 81. X to the 1 squared gives you x squared. Y to the 1 squared gives you y squared. Example C, negative 4z quantity squared means negative 4z times negative 4z. Negative times negative is going to yield a positive 16z squared. We can still use the same property that we used on B. This square goes to every entity in this set of parentheses. That means that when you square a negative, you get a positive product. When you square 4, you get 16, and you square z to the 1, you get z squared. This is different than example D, where the negative sign is not included in your group inside your parentheses. That means the negative comes straight down, and that square does not apply to it. It only applies to the 4 and to the z. So you have 4 squared, giving you 16, and z to the 1 squared, resulting in z squared. So the only difference in C and D is that the negative sign is inside your grouping symbols, inside your parentheses, and that negative is squared. Anytime you square a negative, it turns to a positive. In D, the negative sign is outside your grouping symbols, and so the square does not apply to that negative, and the negative comes straight down. This is example 4 on page 491. It looks a little like a monster, but it's actually not too bad. You just have to do it piece by piece and step by step. 2x to the third quantity squared. Let's take care of that first. 2x to the third times 2x to the third. That is what the quantity of 2x to the third squared means. So you would have 2 times 2 is 4, and x to the third times x to the third is x to the sixth. Again, we could go back and apply that same property. 2 squared is 4, and x to the third quantity squared is x to the sixth. When you have a power raised to a power, you multiply the numbers. Now that we have cleaned that up and simplified it, we're going to bring down our x to the fourth. So our constant is 4. X to the sixth times x to the fourth. We have the same base with our x, which means we will be adding our exponents. 6 plus 4 is 10, and that is as simple as we can make it. Y'all have a great day.